Hello, welcome to the next section, Databases and Neural Networks. In this section, we will look at and define Artificial Neural Network, ANN, and draw data from a data developer's knowledge of data, databases, and data models. Now we move on to the first video, defining neural networks. So, what exactly is an artificial neural network? Perhaps a computer system modelled on the human brain and nervous system. A popular definition is: in machine learning and cognitive science, artificial neural networks, ANNs, are a family of models inspired by biological neural networks, the central nervous systems of animals, in particular the brain, and are used to estimate or approximate functions that can depend on a large number of inputs and are generally unknown. So, there are many definitions, but in summarization, the common theme through all of the definitions you'll find for an ANN is that it is defined as a computer data model based upon the concepts of how a human brain works. Take a look at the image. This suggests the construction of a typical artificial neural network is based on some number: nodes, layers, connections. First, let's learn about nodes. Each of the layers is made up of a number of interconnected nodes, each node containing what is referred to as an activation function. There will be at least one node in the input layer for each predictor variable that exists within the data. The input nodes feed the input values to each of the nodes in the next hidden layer. The inputs to each node are summed to give a single value, x. This is then inputted to the node's activation function, and the output of the node is the output of its activation function, fx. There are a number of functions that can be used in artificial neural network nodes, including the radial basis function or a simple linear function, but the most common is the sigmoid or logistic function. Next, let's look at layers. The layer is a universal term used to define a collection of nodes operating together at a specific depth within an artificial neural network. Hidden layers will have a variable number of nodes. Each of those nodes will contain numerous functions with logic to process the inputs and calculate a result. The resulting value is then passed to the next layer. We will now look at the layer summary. Input layer contains your data with one node per variable. Hidden layers. Each layer attempts to learn a different aspect about your data by minimizing an error cost function. Output layer. This is the simplest layer, usually consisting of a single output for classification problems. Now we move on to training. If all the nodes work the same way, or at least produce the same result, 0 or 1, how does the network differentiate between classes? It uses assigned weights to each node's inputs. This is a feature or variable in the data that can have a large or small weighting, which then results in varying the contribution that the variable or feature makes to the sum in any node. In practice, a variable can be assigned a large weight feeding into one node and an almost zero weight feeding into another node, which would mean that the variable would have a strong influence on the first and practically none of the second. Training the artificial neural network is the process of systematically discovering the best values of weights to maximize the accurateness of classification. As we noted, neural network models are a system of processing nodes, interconnected across layers that do not process data in a sequential manner. How does this scheme compare to a conventional database model or program? In the technology industry, a conventional database model is sometimes called a serial processing component, which means that this type of model has a central processing unit, or CPU, that accesses raw data and instructions. In a conventional database model, the central processor carries out calculations or logic, an algorithm, on input or selected data, stores the calculated results in a specified memory location, then goes on to the next instruction and data, and so on, until a solution or result is reached. So, in a serial system, the computational steps are deterministic, sequential, and logical, and the state of a given variable can be tracked from one operation to another. In comparison, ANNs are not sequential or necessarily deterministic. There are other key differences, which includes no single or main node. Rather than a single complex central processor or node, there are many simple nodes, which generally do nothing more than taking the weighted sum of their inputs from other nodes. Not serial. ANNs do not execute programmed instructions linearly or serially. They respond in parallel, either simulated or actual, to the inputs presented to them. No memory address to store results. There are also no separate memory addresses to store data within an artificial neural network model. Instead, information is contained in the overall activation state of the model.